Example 3.2 says, suppose that you are offered the following investment opportunity. If you invest $1,000 today, you can receive $1,070 in 1 year. Should you accept this investment opportunity? Okay, well, we're going to use the same value equation to evaluate this investment opportunity that we did in example 3.1, and that is where the value of a particular trade is equal to the benefits, that is what you receive, minus the costs, that is what you give up. And in this case, it is awfully tempting to just plug in dollars. So what we get, what we'll receive is $1,070 in 1 year. What we have to give up is $1,000 today. And so it looks like the value of this trade is $70. That is, we're $70 better off than we would have been if we did not accept the investment opportunity. Now this one is definitely deceiving. We're used to thinking of dollars as a complete description of the units attached to cash flows. What we're going to find out is they're not a complete description of the units any more than 1 unit of Ether is a complete description of units, or 1 unit of Bitcoin is a complete description of units when you're trying to compare those. They're actually 2 different units, that is, units of Ether and units of Bitcoin are 2 different things, and we have to convert them to common units, usually dollars, like we did in example 3.1, before we can compare them. What we're going to find out is the same is true with cash flows over time. Dollars today are not the same thing as dollars in 1 year. And if we pause for a minute and think about it, we're all aware of this, right? There's, if we're going to be asked to give up dollars today in order to receive dollars in the future, well, so for example, the poll at the beginning of this chapter asked, if you gave up $100 today to invest in Stelk Inc., how much would you demand to be paid in 1 year in order to give up those $100 today? And if you happen to look at the results of that poll, almost nobody said, oh, you could just give me my $100 back in 1 year and I'll be okay. No, pretty much everybody wanted a much higher payment than $100 in order to give up their $100 today. In most cases, it was, $150, $200. So it was like a 50 to 100% rate of return in order to give up the $100 today. An opportunity cost is one of the main drivers of what we call the time value of money, where the time value of money is the difference in value of dollars today versus dollars in 1 year. So what we need to account for before we can make this value decision is what is our opportunity cost for this money. That is, what are we giving up in order to make this investment decision? So we need a little more information. Let's suppose that our bank that we bank at is offering 10% on all deposits, 10% interest per year on all deposits. Okay, and we're going to simplify our world a little bit and say that these are our only 2 options. And obviously that's not realistic. We have lots of options for our money. But just to simplify things and get our arms around the concept of what's going on here, we're going to say these are our only 2 choices. We can either accept the investment opportunity, or we could deposit our $1,000 in the bank and earn interest on it. Okay, so now what we need to know, we know the benefit of the investment opportunity. If we give up $1,000 today, we'll receive $1,070 in 1 year. What we want to know now is, what is the cost of that? What are we giving up? If we instead were to deposit our $1,000 in the bank, what would we have in 1 year? All right, well, in 1 year, we would get 10% interest. All right, so the amount of interest that we would receive is our $1,000 that we would deposit in the bank. We would receive 10% interest. 10% expressed as a decimal is 0.1. 0.1 times 1,000 is 100. So over the course of the year, we would earn $100 in interest. And so then our bank balance in 1 year would be the $1,000 we started with, plus the $100 in interest that the bank would credit us. And so in 1 year, in our bank account, we would have $1,100 sitting there. Okay, now we can directly compare the benefits and the costs because we have cash flows happening at the same time period. Our benefit of the investment, the $1,070, happens in 1 year. And then in our bank account, if we instead put that $1,000 in there, we would have $1,100 in the bank. So let's draw both of these options on a timeline. Time period 0 is today. That's what happens up front. And then we'll use a 1 for 1 year. What happens 1 year from today? And so we have the investment. For the investment, we would give up $1,000 today, and we would receive $1,070 in 1 year. This is the benefit of the investment. If we instead of taking the investment were to invest our $1,000 or put our $1,000 in the bank, that $1,000 would sit in the bank. They would earn us interest, a arithmetic shortcut for what we did here, where we calculated the interest of $100 and then added it back to 1,000. We can just multiply that 1,000 times 1 plus whatever the interest rate is, in this case 10%, so times 1.1, and that is going to give us the 1,100 that we calculated just above here, and that is the cost of this investment opportunity. That is, this $1,100 that we could have in our bank account is what we give up by accepting the investment opportunity. And now that these two cash flows are expressed in the same time period's dollars, we can plug them into the value equation. All right, so the benefits minus the costs. Now we've got the benefits of $1,700 in 1 year minus the cost of $1,100 in 1 year is equal to a minus 30, right? So 1,070 minus 1,100, that's minus $30 in 1 year. All right, so now that we've converted in the same units, we would say, no, we don't want to take this investment opportunity because we're giving up $30 that we could otherwise have. Okay, so what's going on here? Well, just like in example 3.1, where we had to convert units of Ether and units of Bitcoin into common units of dollars with a conversion factor before we could compare them, it turns out we have to do the same thing with cash flows. We have to convert dollars today into dollars in 1 year and compare all dollars in 1 year. Or vice versa, we convert dollars in 1 year into dollars today and compare just dollars today. But in this example, we're just looking at moving from dollars today into dollars in 1 year. And then in a future example, we'll look at moving the other direction. Well, in the previous example, we used the market price of Ether and the market price of Bitcoin as the conversion factor to convert from units of Ether to dollars and units of Bitcoin to dollars. When we're talking about cash flows over time, the interest rate is that conversion factor that allows us to convert from dollars today into dollars in 1 year. And it carries units just like the market price of Ether and the market price of Bitcoin did. So let's lay down some definitions before we see how this works. Let's say that the little letter R is our interest rate. And then we have a conversion factor that we call the interest rate factor. And that thing is 1 plus R, or 1 plus the interest rate, expressed as a decimal. And this guy carries units. It carries units of dollars next period over dollars today. All right, now let's plug in the numbers from this example to see how this works, and we'll find out it works just like it did with units of Ether and units of Bitcoin. So if we're looking at this investment opportunity, we've got the benefits already expressed in dollars in 1 year. Let's take the cost of this investment and convert it into dollars in 1 year, just like we did here, but we're going to use the interest rate factor to do it and see how this cancellation works. All right, so let's look at the costs. Let's say we're going to convert the cost into dollars in 1 year. All right, so we have a cost of 1,000. That's what we're going to give up today, and that has units of dollars today. And we're going to multiply that times our conversion factor here, just like the market price of Ether or the market price of Bitcoin. We're going to multiply it by the conversion factor of 1 plus our interest rate, or 1 plus 0.1, 10%. And this thing is going to carry the units of dollars next period. In this case, that's dollars in 1 year. Because 1 year is next period, over dollars today. All right, just like we did in example 3.1, these units of dollars today, I'm going to write over 1 just to express it as a ratio, and we haven't changed the value of this. Anything over 1 is just itself. But what we can see now is we have dollars today in the numerator here on the 1,000, and we have dollars today in the denominator on our interest rate factor. And so when we multiply those things, they cancel out. And what we're left with is 1,000 times 1.1 dollars in 1 year. Right? Those are our only units left. And 1,000 times 1.1 turns out to be 1,100. And that's dollars in 1 year. Right? So now we have expressed the costs in dollars in 1 year, which are the same units as those expressed, as the benefits are expressed in. The ones that 1,070 is dollars in 1 year. And so just like we did above, we can plug that directly into the value equation. Where the benefits are $1,070 in 1 year minus $1,100 in 1 year, right? Because that's what we're giving up. And we get a value of negative $30 in 1 year. Right, now the second calculation we've gone through is exactly what we did above. We didn't have to do it again. What we wanted to see was how this interest rate factor allows us to convert from dollars today into dollars 1 year, so that we don't have to, for every problem, think through, okay, if I deposit the money in my bank, I credit interest, and then I add those together to get the account balance in 1 year, and then I can compare the benefits and the cost. Instead, we can just go right to converting the cost or the benefits, either one, whichever one you want to look at. Convert one of them into dollars in 1 year, and then we can compare them directly. So this last part, just starting right here, we convert cost to dollars in 1 year. This is really the only calculation that was necessary in order to answer the question. We didn't have to do everything above. Everything above was just to get a feel for what's going on with the calculation. Okay, that's it for this one.